Good day all. Did you ever consider how a musical instrument is built? Well, in this session, I am presenting a method to improve the quality of musical instruments. I am Poon, and my research is focused on the manufacture sector. If you follow this, we will look at multi-criteria decision-making models in QFD with a fuzzier approach applied to musical instruments. The images above show different varieties of the guitar, and each of them illustrate a different style and perhaps a different emotion. Today we are going to look at the best process to manufacture a musical instrument, determine the best features or variables, and build a model to evaluate the manufacture of the instruments. This presentation is based on the early stage of my research. I have collected information on the science and manufacture of instruments, decision making, especially dealing with people, and MCDM. This slide shows the 5 categories for musical instruments. This figure shows how expression and musicianship depend on physical control and tonal response, and they both are functions of forces, pitch, sound clarity, and duration of the instrument. This table shows the dependency levels between the physical parameter and perceived quality of musical instruments. We see pressure, loudness, frequency, pitch, spectrum, timbre, duration measured, and duration have high levels of dependency. This points to the parameters to which we could use in our model. To satisfy the engineering categories in the model, I use Gershensen's taxonomy. QFD was simply used to translate the customer needs into the product features. This table shows the integrated QFD inputs. It comprises of 4 QFDs. The product design QFD, the customer requirements are translated into the design requirements. And these design requirements are then introduced to the part deployment QFD, which are translated to product characteristics for the process planning QFD. These product characteristics are translated to the manufacturing operations to create the operation planning QFD and used to give the operations and control parameters. Now let's take a look at the proposed fuzzy QFD-TOPSIS-AHP model. Starting on the top left, multiple groups formed by customers identify and provide fuzzy data for the watts. This fuzzy watts data is aggregated and normalized. The normalized watts data is parameterized using fuzzy AHP. Then, on the top right, multiple groups formed by designers identify and provide fuzzy data for the house referring to the parameterized watts in the previous step. The house data is aggregated and normalized. Then, the normalized house data are correlated with fuzzy AHP. Both normalized watts and house relations are evaluated with fuzzy TOPSIS. Then the competitive satisfaction performance is scored by the level of customer satisfaction between the developed product and existing products. And on the right of that, the hows are ranked with absolute weights of the correlated fuzzy AHP and related fuzzy TOPSIS. And this now forms the fuzzy QFD-TOPSIS-AHP model. Now I would attempt to map the model. On the left side is the QFD, and at the side of each room there's a symbol. Each symbol is correlated in the model so we can identify the activities done. To complete the 4 QFDs, these are the steps. The product design QFD, we start with customer requirements. And this is then followed through the model, giving us the design requirements. These design requirements now become the inputs for the part deployment QFD. And when it goes through the cycle again, the output becomes the product characteristics. And these product characteristics are now the inputs for the process planning QFD. When passed through the system again, gives us the manufacturing operations, which now become the inputs for the operations planning QFD. Completing the cycle, giving us the operations and controls parameters. The fuzziness in the model allows us to receive the psychological component of the customer needs. We can now interpret the perceived qualities of the customer, assessing their affection, cognition, and emotional states. The benefits of QFD allows us to process customer views, which improves the product performance. Fuzzy, importantly, allows subjectively vague data into the model and simultaneously retrieve data from different levels of groups. TOPSIS allows us to rank real situations and measure the relative distances to the ideal solution. AHP allows us to perform a pairwise comparison and computation tests to validate the internal ranks. In conclusion, we have a fuzzy QFD-TOPSIS-AHP model, and we can now capture and incorporate views from musicians, manufacturers, audience members, and entrepreneurs in one model. Next, I would like to develop a case study on a common instrument. This is to validate the model and determine the deficiencies involving bias, since we will be looking at the perceived values from people. Here are the references. Now I would like to close by saying that this model does not only apply to musical instruments. I would also like to thank you, the Icon eTech team, and Dr. Terrence Lalla.